let's move ahead with modern periodic table part 1. Okay. So history of modern periodic table, from where did this came from? So in 1913, Henry Moseley showed that the atomic number of an element is a more fundamental property than its atomic mass. He considered atomic number as the prime factor of the modern periodic table. So Mendeleev's periodic law was modified and atomic number was adopted as the basis of the modern periodic table. That you need to remember this. All right. So modern periodic law. Properties of elements are a periodic function of their atomic number. This is very important. Whereas in Mendeleev's, what was that? Properties of elements are a periodic function of their atomic mass. Okay. So atomic number gives us the number of protons in the nucleus by an atom, and this number increases by one in going from one element to the other. So how do we demonstrate atomic number? This is the atomic mass and this is the atomic number, and X be it any element. Okay. So elements, when arranged in order of increasing atomic number, lead us to the classification known as modern periodic table. The modern periodic table has 18 vertical columns known as groups that you need to remember, and 7 horizontal rows known as periods. As soon as you will start reading the periodic table and you will practice more and more the questions on the basis of it, then you will get to see that you will be very fluent in your periodic table thing. Okay, so 18 vertical columns known as groups and 7 horizontal rows known as periods. Okay. So modern periodic table something looks like this. It is a very serene serene scene to know, right? So this is hydrogen, this is group 1, 2. These are periods, these are groups. Alright, these are lanthanoids, these are actinoids, and these are transition metals, alkali metals, alkali earth metal. Okay, the zigzag line shows us lanthanoids that you will see ahead. So suppose you have, let's do an activity 1. This is observation here. This is lithium, sodium, potassium, rubidium, cesium, and francium. So what do you understand by it? Okay, so there is a similarity in the electronic configuration because all of these elements have one single electron in their outermost shell. So all these elements contain the same number of valence electrons. Okay, let's do activity 2. So elements of second period do not have the same number of valence electrons. So conclusion, the elements contain the same number of shells. The number of valence shell electron increases by 1 unit as an atomic number increases by 1 unit on moving from left to right in a period. So when you move from left to right in a period, you will get to see that one electron is getting added. So what do we say, that all the properties will be same in a group, but when you go from left to right, then you will see that there is a gradual increase in one electrons in every group. So you will see here that this is lithium, it has the configuration of 2-1, whereas beryllium has 2-2. Boron has 2-3. Okay. So number of elements in periods. So the number of elements in these periods based on how electrons are filled in various shells. The maximum number of electrons that can be accommodated in a shell is 2n square, where n is the number of the given shell from the nucleus. So second period has 8 elements. Third, fourth, fifth, and sixth, seventh have 8, 18, 18, 32, 32 elements respectively. Okay, so this was all thing about the period. You need to get this. So form the words using the elements. So this is beryllium. We chose these two. For erbium, we choose ER, molybdenum, MO, thorium, TH. So these are the words that we use in the place of writing the whole name of the element every time. So atomic number of hydrogen is 1 and has only one valence electron. So it belongs to the first row and the first period of the periodic table. Okay. So modern periodic table indirectly solved the conflict of the Mendeleev, that Mendeleev was confused where to place hydrogen. So, but the position of hydrogen element is not fixed yet in periodic table due to the resemblance of hydrogen with many groups in properties like alkali metal and halogens that are present in the last. So just before the what inert gas group. So hence hydrogen was put at the top of the periodic table so that the symmetry of the modern periodic table is not disturbed. Okay. So trends in the periodic table. It has valency, atomic size, and metallic and non-metallic characteristics. These are the characteristics on which we are going to discuss in the periodic table. So let's go ahead with activity 1, that is valency. So what do you see here? Here is alkali metals and alkali earth metals. Then you can see that here is the gradual increase in electrons, 1 1. Okay, but in the period it is the same. So these are the variation. Note the variation in the valency in a period on going from left to right and going down in the graph. Okay. So valency. Valency of an element is determined by the number of valence electron present in the outermost shell of its atom. So magnesium has 2 valence electron, hence its valency is 2. Okay. Suppose you take example of aluminium. Aluminium has the valency of 3 because it has 3 electrons in its outermost shell. Also, across a period, the valency increases while down the group valency remains same. Okay, so valency of sulfur. Sulfur atom has 6 electrons in its outermost shell. Okay, and its valency could be 6. It is easier for sulfur to gain 2 electrons instead of losing 6 electrons. So valency of sulfur, it's 8 minus 6, that is 2. Okay, let's move ahead with modern periodic table part 2. Atomic size. So here the atomic radius decreases in moving from left to right. How decreases? That I'll get back to you. Okay, so this is due to an increase in nuclear charge which tends to pull the electron closer to the nucleus and reduces the size of an atom. So when this inter inter force is there, then you will see that it is not easy for an element to lose an electron. So there is the case here. So note the atomic radius can change. Note the atomic radius change as you go from left to right in a period. Okay. Whereas here you come and you will see that there is not much interforce that is dragging, and that is dragging them to okay, I just said wrong. So here I'll just explain this. So all the elements here you can see is a gradual increase. Here is because they don't have this interforce that is driving them to shrink. Okay. And when you will go from left to right, there is a gradual decrease in atomic size because there is decrease in atomic radius because of interforce. So atomic size, radius of an atom, it is the distance between the center of the nucleus and the outermost shell of an isolated atom. The atomic radius of hydrogen atom is 37 picometer. Picometer is 10 to the power, raised to the power 12 meter. Okay. So activity atomic size variation with group. Note the variation in the atomic size as you go down a group. The atomic size increases down the group because there is increase in the electrons. So this is based because new shells are being added as we go down this group. This increases the distance between the uh, outermost electrons and the nucleus so that the atomic size increases in spite of the increase in nuclear charge. So activity, metallic and non-metallic properties, observation, note on which side of the periodic table you find the metals and non-metals. Okay. So change in the tendency to lose electrons in a group and a period. Conclusion. The metals like Na and Mg are towards the left-hand side of the periodic table, while the non-metals like sulfur and fluorine are found on the right-hand side. Metallic and non-metallic properties, we discussed atomic radius just now. So a zigzag line separates metal and metal from non-metal. So the borderline elements boron, silicon, germanium, arsenic, antimony, tellurium, and polonium are intermediate in properties and are called metalloids. These are metals. These are metalloids. This is a non-metal. Okay. Trends in periodic table, that you will see that ionization energy increases as soon as electron is getting added into the outermost shell because of the interforce that it will have. So because of it, the atom would let a electron to get loose. So because they all are getting desperate to get an electron and become inert. So this is atomic radius. Electron affinity goes this atomic radius. This is very important and very convenient to write in exams. So metallic properties. Metals tend to lose electron while forming bonds, that is, they are electropositive in nature. Metallic character decreases across a period and increases down a group. As the effective nuclear charge acting on the valence shell electron increase across a period, the tendency to lose electron will increase. Okay. So down the group, the effective nuclear charge experienced by valence electrons is decreasing because the outermost electrons are farther away from the nucleus. Therefore, they can be lost easily. So this is why it is it. So not non-metallic properties here. So non-metallic on the other hand are electronegative. They tend to form bonds by gaining electrons. So as the trend in the electronegativity shows, non-metals are found on right hand side of the periodic table towards the top. Okay. So let's move ahead with questions. That is the best thing, right? So how could the modern periodic table remove various anomalies of Mendeleev periodic table because the hydrogen conflict was solved. Hydrogen conflict was solved, and also okay, so here hydrogen, and it is okay. So here I am taking some time to regain my memory that how could a modern periodic table remove various anomalies of Mendeleev periodic table because there is no hydrogen conflict. It is placed, and here we can say that atomic number, because of the atomic number, we are saying that modern periodic table has turned out to be more informative and resilient in compared to the other scientists. Okay. So name two elements which you expect to show chemical reaction similar to magnesium. What is the basis of your choice? So this is sodium, magnesium. Okay. No. It is calcium and strontium because they are found in same group. Okay. So name three elements that have a single electron in its outermost shell, Na, two electrons, Mg, three electrons filled with neon, that you will understand as soon as you practice this one word questions. Okay. So lithium, sodium, potassium are all metals that react with water. Is there any similarity in the atoms of these elements because it has a single electron present in its outermost shell? Okay. So helium is an unreactive gas and neon is a gas of extremely low reactivity. So what if anything do their atoms have in common? They are both inert gas and unreactive. Okay, that you need to remember. So in modern periodic table, which are the metals among the first 10 elements? Okay, so here it is. Mm, it a metallic. Um, it is a metallic character, right? So whenever metallic character question comes in, you will have to check this from first 10 elements. So from first 10 elements, you can see that only on the left hand side, the um, you know only the left hand side there will be the metallic character. So beryllium and gallium, these are metals among the first 10 elements. Okay. So by considering their position in periodic table, which one of the following would you expect to have minimum metallic characteristics? Okay. So here beryllium and gallium will have the maximum metallic character because it is present in the left hand side. Actually, I made a problem. Okay, so first 10. Okay, first 10. I am really sorry. It will be lithium here. Okay. So quick revision of the whole chapter. So elements are classified on the basis of similarities in their properties. Doberaners grouped the elements into triads and Newlands gave the law of octaves that you need to remember. And there is just simple subtopics in this chapter, okay, that you will need to understand. Is it the importance of elements, why elements are necessary to have been to have organized to be placed in a group, in a particular group in a period. Then thing is that you will have to study the theories given by the third theories given by the sir about um, you will see it here. So there is Dobereiner, Newman, okay, then Mendeleev, then Huxley. So Dobereiner grouped the element into triads and Newlands gave the law of octaves. So Mendeleev arranged the elements in increasing order of their atomic mass and according to their chemical properties. So anomalies in arrangement of element based on increasing atomic mass removed could you removed when the element were arranged in order of increasing atomic number. A fundamental property of the element discovered by Moseley. Okay. So every element in the modern periodic table are arranged in 18 vertical column groups and 7 horizontal rows called periods. Okay. Elements thus arranged show periodicity of properties including atomic size, valency or combination capacity, metallic and non-metallic character. Okay, so this is it. Thank you.